This video is a short introduction to p-values. We'll cover what is a p-value, significance levels, one-sided and two-sided tests, calculating a test statistic and interpreting p-values. Section 1. P-values. When you perform a hypothesis test in statistics, a p-value, or probability value, helps you to determine the significance of your results. Hypothesis tests are used to test the validity of a claim that is made about a population. All hypothesis tests ultimately use a p-value to weigh the strength of the evidence. A p-value is a number between 0 and 1. It indicates the probability of observing a difference if no difference exists. The example we're going to use today is a study looking at the difference in height between men and women. Our null hypothesis is that men and women are the same height. That is, there is no difference. Our alternative hypothesis is that men are taller than women. Our study has 200 adults, 100 men and 100 women. We've measured and recorded the height of all our study participants. The average height of the 100 men in our study is 175 centimetres. The average height of the 100 women in our study is 161 centimetres. As you can imagine, the heights of the men and women vary within our sample of 200 people. We need to perform a statistical test to work out if the difference in height in men and women is statistically significant or not. By statistically significant, we mean a result that is not attributed to chance. Section 2. Significance levels. The significance level is a probability of rejecting a null hypothesis that is correct. So that means saying there is a difference when there actually isn't. Significance level is denoted by the Greek letter alpha. Significance is usually set at 0.05. A significance value of 0.05 means 5 out of 100 times you will see a difference, even though the null hypothesis is true. So you will say there is a difference when there actually isn't 5% of the time. A significance value of 0.01 means 1 out of 100 times you will see a difference, even though the null hypothesis is true. The lower you set your p-value, the more confident you can be in your answers. Section 3. One- and two-sided tests. Alternative hypotheses can be one-sided or two-sided. A one-sided test means the difference is only in one direction, that is, greater than or less than, but not both. Let's use our example. In this situation, our alternative hypothesis is a one-sided hypothesis, as we are predicting that men will be taller than women. On a graph, this is what a one-sided test looks like. In the middle is the null hypothesis, that men and women are the same height. On the right-hand side, the blue shaded area represents where the p-value needs to fall for the alternative hypothesis to be true, that is, men are taller than women. If we had set our significance level to 0.05, the blue shaded region would represent 5%. Two-tailed tests, also known as non-directional, are two-sided because you can test for effects in both directions. The null is that the effect equals 0, or no difference. The alternative is that the effect does not equal 0. Imagine you want to test the effectiveness of a new drug compared to an existing drug. You could perform a one-tailed test to see whether the new drug performs better than the existing drug. In doing this, you fail to test the possibility that the new drug is actually less effective than the existing drug. A two-tailed test would allow for both possibilities. The new drug could perform better or worse than the existing drug. In this case, the null hypothesis would be there is no difference in performance between the new and the existing drug. The alternative hypothesis would be there is a difference in performance of the two drugs. Let's see what a two-sided test looks like on a graph. When you perform a two-tailed test, you split the significance level percentage between both tails of the distribution, shaded in light blue. This is why it is written as alpha divided by 2. If our significance level was set at 0.05 or 5%, then each area would equal 2.5%. When a test statistic falls in either critical region, you can say that the new drug performs either significantly worse or significantly better than the existing drug. If the test statistic falls in this middle range, we fail to reject the null hypothesis, and we would say there is no difference in the performance of the new drug and the existing drug. Section 4. Test statistics. Typically, hypothesis tests take all of the sample data and convert it to a single value, which is known as a test statistic. You're probably already familiar with some test statistics. For example, t-tests calculate t-values, f-tests such as ANOVA calculate f-values, and chi-square tests produce chi-square values. All of these values are test statistics. Probability distribution plots display the probabilities of obtaining a test statistic when the null hypothesis is correct, that is, there is no difference. On a probability distribution plot, the portion of the shaded area under the curve represents the probability that a value will fall within that range. In hypothesis tests, critical regions are the ranges of the distributions where the values represent statistically significant results. Section 5. Interpreting results. To interpret the results, simply compare the p-value to your significance level. If the p-value is less than the significance level, you know that the test statistic fell into a critical region. Using our height example, let's look at how we could interpret a one-sided test. Let's quickly review the regions on the probability distribution. On a one-sided test, we are only interested in looking in one direction. Are men taller than women? We are not at all interested in finding if in fact men are shorter than women. So if the test statistic falls below 0, we're not interested. This can't tell us anything about our hypotheses. If the test statistic falls in this region, between 0 and our significance level, we would say that the heights of men and women are the same. We fail to reject our null hypothesis. However, if our test statistic falls above the significance level, we can reject our null hypothesis and say that men are taller than women. For a two-sided test, the regions on the probability distribution are slightly different. Let's explore this further using our example on new and existing drugs. If the test statistic falls in this middle region, either above or below 0, the performance of the two drugs is the same. We fail to reject the null hypothesis. If the test statistic falls in this region, below the significance level, we reject the null hypothesis. Our conclusion would be that the new drug performs significantly worse than the existing drug. If the test statistic falls in this region, we also reject the null hypothesis. Our conclusion would be that the new drug is significantly better than the existing drug and may have implications for clinical practice. A final tip. A small p-value, typically less than 0.05, indicates strong evidence against the null hypothesis. So you reject the null hypothesis and say there is a difference. A large p-value, greater than 0.05, indicates weak evidence against the null hypothesis. You fail to reject the null hypothesis and say there is no difference. This video was brought to you by Study Smarter UWA. For more videos, subscribe to our channel or visit studysmarter.uwa.edu.au.